The second pink card, the one we started yesterday. Okay, well, you still need space to fit more, though. So yesterday we called them sum and difference because we had alpha plus beta or alpha minus beta. These ones are called double angle because they've got this little 2 in there. That's like the worst arrow I've ever drawn. Okay, so we're taking the angle and timesing it by 2, and when you times something by 2, it's called doubling, right? So that's why they're called double angle identities. Formula for sine 2 theta is 2 sine x cos x. Where does that come from? Well, it actually comes from the alpha plus beta formula we looked at yesterday. Who can remember the other side without peeking down at their card? Okay, we need to put some things. Oh, ooh, you guys have good memories. Just double check that's correct. Okay, now what a double angle means is that on the left-hand side, these are both alpha, or both beta, or both x, or both theta. They just mean they're exactly the same angle. And so if I'm to simplify this on the left, what's alpha plus alpha? 2 alpha. So that's where the formula is actually coming from. And let's see what's going to happen on the other side. What this means is that every angle is going to be alpha. So sine alpha cos alpha plus cos alpha sine alpha. Okay, that's what a double angle means, is that we're using the same angle twice. Every angle in the formula becomes alpha. Or smiley face. Now these are just 2 terms. So if I look at the first one, it's sine alpha cos alpha. And the second term is cos alpha sine alpha. And adding means I'm just going to simplify them. So what is one sine alpha cos alpha and another sine alpha cos alpha? It's 2 of them. And that's where the formula comes from. So it's actually just the sum and difference formula that we've just tweaked a little bit. Okay, this is going to go on the back of your card. X, theta, alpha, beta, whatever you want to use. Smiley face, whatever you want to use. Bless you. Now we're going to do the exact same thing with cos. This time I'm going to start with the proof before we get down to the formula. So let's start with the cos alpha plus beta formula. Who remembers without looking down at their pink card? Ooh, cos alpha, cos beta. Ooh, minus, got it. Sine alpha, sine beta. On the left, I'm just going to put alpha for both because that's called a double angle. And then I'm going to simplify on that side, so alpha plus alpha. Not a trick. Alpha plus alpha, 2 alpha. And so on the right, I'm just going to replace every angle with alpha. So I get cos alpha, minus sine alpha, sine alpha. This is a multiplication, and this is a multiplication, and we have a subtraction in between. What do we do first? Multiply. So what's cos times cos? I don't care if it's alpha, x, theta. What's a cos times cos? Cos squared, so this is going to be cos squared alpha. And the second multiplication is a sine times sine. That becomes sine squared alpha. Oops, sine squared alpha. Can I simplify this? Oh, does that equal 1? Yeah, and your brain will want to think it's equal to 1, but that's cos squared plus sine squared. So can I do anything with this? Can I smush them together? Nope, so that is our first formula for cos 2x. is cos squared x minus sine squared x. And if your brain was like, hey, that's 1, just make yourself a note off to the side that 1 is cos squared plus sine squared. Well, I can't simplify this, but we can play around with it. Let's imagine I want to get this sine squared out of here. I don't like sine. Ugh. What can I do with just a sine squared? Is there an identity I can change it for that has cos in it? 1 minus cos squared. So I'm going to leave the left-hand side. I'm going to leave the first term of our cos squared. I'm going to leave our minus sign. And then in brackets, I'm just going to swap in that sine squared we know is 1 minus cos squared. So distributing this negative to get rid of the brackets, I've got a cos squared in front. Minus times 1, minus 1. Minus times negative cos squared, positive cos squared. Oh, someone's ahead of me. I have 1 cos squared and I have another cos squared, and I put them together. What do we have? 2 cos squared theta or x or theta or alpha or beta minus 1. That gives us our second formula for cos 2x. 2 cos x squared minus 1. What? There's 2 different formulas? Oh no, just wait, there's 3. So I'm going to go back to this first one. I'm going to do the opposite of what we just did. This time I want to keep sine. I want cos out of there. So how can I get cos squared out and maybe something with sine in? 1 minus sine squared. Okay, so cos 2x is, and I'm going to put brackets in, exchange the cos squared for 1 minus sine squared, and then keep that minus sine squared at the end. And then I can just drop the brackets because there's no coefficient in front of it. So I get 1 minus sine squared minus sine squared. And if I just put these together, if I have 1 minus sine squared and then another minus sine squared, how many sine squareds do I have? So I have 1 minus 2 sine squared. And that is our third and final formula for cos 2x. Oops. So the double angle for sine has 1 formula. The double angle for cos has 3. And it's really just the same formula. We've just played around with it and made it look different. All these 3 are going to go back on the back of your card. So cos 2x is cos squared minus sine squared, or 2 cos squared minus 1, or 1 minus 2 sine squared. When we do the examples, I'll show you how to know which one you're going to use because it just depends on the situation. Again, they're all the same formula. We just played around with what they look like. Are these on your formula sheet? And I'll be more specific, are all of them on your formula sheet? So we have a yes with kind of a question mark at the end. Okay, and do you notice they're all kind of grouped together? So you can notice the Unit 1 formulas were at the top, and now we're into Unit 2, and all the formulas are together. So you can use your formula sheet, or you can use your pink cards on the test, whatever one you like better. Oh, but what about tan? We can't forget about tan. That would make tan sad. We could do the same thing, take the tan alpha plus beta. I'm just going to jump to the chase here. If we did all the simplifying, it equals 2 tan x divided by 1 minus tan squared x. And again, it just comes from the tan alpha plus beta and representing the double angle and then simplifying. And that will be the last formula to go on the back of your second pink card. And we're done trig formulas. That is it. That is all of them you need to know on those 2 pink cards. Back in the day, which I know makes me sound old, we didn't get formula sheets. We just had to know all this stuff. Well, she's Romanian, and in Europe they don't get formula sheets at all, ever. Okay, I just want you to read the examples. And you'll notice they're very similar to the questions we did yesterday. So the first one is finding exact values. Second one is proving. Third one's also proving. Fourth one is solving. So we can find exact values just like before, we can prove identities, and we can solve trig equations. Okay, so exactly like the sum and difference kinds of questions, we're just going to use these new formulas. So example number 1. Okay, so we're given that theta is in quadrant 3. Why might that be important later on? It's going to be something with a sign, so it's going to change a sine or cosine depending. We're given sine of theta is -1/3. And question wants 2 things. First, it wants the value of sine 2 theta, and then it wants tan 2 theta. So this is a straightforward formula kind of question, just like the first one was yesterday. So look at the back of your second pink card. Tell me what the other side of sine 2 theta is. 2 sine theta, cos theta. Sine theta will be a fraction, cos theta will be a fraction, and then we'll simplify. Just like yesterday we had 4 fractions that we were substituting, now we have 2. Do I have either of these? Yes, I have sine. Which one do I not have? Cos. Okay, so we come back over to this side. What 2 sides of the triangle did they give me by giving us sine? Okay. We want cos, which is what side over what side? Do we have either of those? Okay, which one do we have? Hypotenuse. Pythagorean triple, question mark. 1 and 3. 1 and 3. No. So if it's not a Pythagorean triple, what do we do? Yeah, well, we did like we do in the first unit. We're just use a squared plus b squared equals c squared. So I know that x squared, or a squared, whatever you want to call it, plus minus 1 squared has to equal 3. So there's 3 squared. -1 squared is? 3 squared is? If I subtract the 1, x squared is? X is? And can we simplify the root of 8? So that allows us to come all the way back up here to sine and say that it's got to be 2 root 2 over 3. I meant cos. Quadrant 3 tells us the sign, whether it's positive or negative. I'm hearing an offer of negative twice. Why negative? Because the cast rule, 2 and 3 is where cos is negative. Okay, this now just becomes direct substitution, so I'm going to keep the 2. I'm going to put in our sine, which is -1 on 3. Put in the cos we just found, which was -2 root 2 over 3. Are we adding? Are we multiplying? Are we subtracting? We're multiplying, so I'm going to put little imaginary 1 under the 2. How do you multiply fractions? And just because we have 3 doesn't change it, so it's just going to be top times top times top, bottom times bottom times bottom. Let's do the bottom first because it's the easier one. Or not. Any offers? 9, yes, I will confirm that is 9. This one, don't let the root scare you. Let's just do the full numbers, the whole numbers first. So 2 times negative 1 times negative 2, positive 4, and what do I do with root of 2? I just leave it 4 root 2. Can I simplify anything in there? Can I reduce 4 and 9? There's the answer of sine 2 theta. Okay, so that's an exact value question. Exact value means take the formula, plug in what you know. Okay, part B is asking for tan 2 theta. What's the other side of the formula? 2 tan theta. And just be careful you're matching your variables. So if we have theta on the left, we have theta on the right. Do I have tan of theta? Okay, can I find it? Okay, what side over what side? Do I have the opposite? What is it? Do I have the adjacent? What is it? Now, I'm not going to rationalize here because this isn't a final answer. So sometimes when we put it over here, something will happen to the root. So I'll rationalize if we need to at the end, but I'm just going to leave it. Okay, so this becomes direct substitution just like above. I've got 2 and then times negative 1 over 2 root 2. Big dividing line. Then on the bottom, I've got 1 minus, and then in brackets, minus 1 over 2 root 2 squared. Okay, now there's a lot going on. We're not going to panic. We're just going to look at the top as one term, and then we'll do the bottom after. So on the top, are we multiplying? Are we subtracting? Are we dividing? What is going on? We're multiplying, so imaginary 1 on the bottom. Top times top, bottom times bottom. Negative 2 over 2 root 2. And what's going to happen with those 2's? Yeah, so I could have actually canceled here before the multiplying if you wanted to. So what's left is negative 1 over root 2. And again, I'll worry about that radical on the bottom when I get to the end. Because it was a negative here? Was it not? Oh, we didn't look at the sign. We didn't look at the sign. Quadrant 3. It should have been positive. Thanks, Noah. Okay, so let's fix that here, and let's fix it there, which means we fix it there. Okay, bottom I've got a subtraction and I've got an exponent. Which do I need to do first? Exponent. So I'm going to leave the 1 in the subtraction. I'm just going to deal with this fraction first. Exponent law from grade 9 says when you have a fraction to an exponent, you square all of the pieces. So 1 squared. And on the bottom I'm going to have 2 squared, 4, times root of 2 squared, which is just 2. And if your brain wanted to put those together right away to be 8, that's fine. I'm just choosing to do it in the next step. So I got a 1 on root 2 on the top, a 1 minus 1/8 on the bottom. I need to still take care of this bottom because it's not one single fraction yet. How do we subtract fractions? Okay, so if I want to make this a denominator of 8, what's going to happen to the top? Would also be 8. And when we subtract, we get, I kind of just heard mumble mumble. 7 over 8. Agreed? Okay, how do we divide fractions? There's something satisfying about flipping a fraction. It just feels really good. Top times top, bottom times bottom. Offer of 8 over 7 root 2. Now here's the deal with rationalizing. You've probably noticed by now that your book does not rationalize. The problem is on the provincial exam, you're not required to rationalize, because if you do and you make a mistake, we have to dock for it. However, university is always going to make you rationalize. So if we never taught you rationalizing, you would go to university and be like, what is going on here? So you can, at this point, have a choice. You can leave it, or you can rationalize. But if you choose to rationalize and you make a mistake, that's a deduction. If you leave it like this, you would get full marks. Okay? So just leave it, but just understand in the real math world, we would never leave it there. The exam just doesn't want to punish you for incorrect rationalizing, because that's not a skill that's in this course. Okay? That's why the book doesn't rationalize, so I would accept this. If you went ahead and rationalized it correctly, I would accept that as well. Okay? So if you had 8 root 2 over 14, also a correct answer. Isn't that kind of exciting? You don't have to rationalize on the exam? A little bit. I know. Example 1, thoughts. Most of this is just fraction work. Okay, let's do some identities. How is this all equal to each other? And who comes up with these questions? Pick a side. Which one looks more complicated to you? Okay, let's go to the right. So let's think about all our things we can do. Change the sign in cos. Done. Look for sine squared plus cos squared. No. Simplify all fractions. No. Try to factor. Okay. Is there anything we can do on this side? Well, there's brackets. So if there's brackets, there's got to be a way to get rid of them. How do I get rid of a binomial squared? We can't square root it because it's not equal to anything yet. What do we call that? Distribution, or what's the acronym that we use? FOIL. This is just a FOIL question. Some brains need to see it written out beside each other. So if your brain is one of those, then just write them out beside each other. If your brain can do the foiling without writing it out, great. So first times first, sine times sine. And then I'm going to do last times last, and I'll tell you why in a second. So cos times cos. The outside, sine times cos. And the inside, cos times sine. Now, the reason I did the F and then the L is because I wanted these to be right beside each other in the order. If you didn't do it that way, that's fine. You could just move it in the next step. But why do I want the sine squared plus cos squared together? Because it's equal to 1, which always makes us happy because it gets 2 terms out of there. And now I'm just going to simplify. If I have one sine cos and another sine cos, how many sine coses do I have? Okay, now what? Ooh, 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 ooh. No, just look at that. What do you see on your card? And QED. Again, just like the sum and difference, these ones are usually some of the easiest identities. I'm totally eavesdropping. Ask me. I'm eavesdropping, ask me. But I want to know what you were asking. Oh, that's just our sine 2 theta. What did you ask me, David? Where did this one? So look on your formula card, what is sine 2 theta equal to? So back, the new formulas we put into the back of the second card. No, sine 2 theta equals? back of the card that we wrote down today. It's the first one. It's equal to 2 sine cos, right? So it's just the formula. Ooh, some of you are already working number 3. You're ahead of me. Cosecant, what now? Do you want to try this one on your own for a bit? No, okay. Can't solve it. Cannot solve it. Why can't we solve this? Just a proof. We can prove it. Okay, if you're already working, work ahead. Just ignore me. If you want to do it with me, let's do it together. Pick a side. Which one looks like there's more good stuff to play with? You want to do the left? I probably would go to the right too, because there's lots of good stuff in there. What do you want to do with it? Well, again, if you look back, right, these identities become repetitive the more you do. So we already had that sine plus cos squared, so probably foiling it.
Can you go right to the next step?
That's exactly what I'm doing, is going right to the simplified one. So I'm just following the steps we did in the last example. So far it's exactly the same. I just have that extra sine 2 theta on the bottom. Cancel? No. Why not? You don't want to kill a puppy. You don't want to kill a puppy. No one in the other class killed 2 puppies yesterday. Just saying. Okay, so if we can't cancel, what do we do?
Move to the other side.
Okay, what would you like to do on this side?
Change to cosecant and sine.
Okay, so what's the relationship between cosecant and sine?
1 over sine.
They're reciprocal, so does the 2 matter?
Yes.
It matters in the fact it's just going to tag along, so this is going to become 1 over sine 2 theta. So all of our new formulas are also the reciprocal formulas. Okay, now what would you like to do?
Change the 1 to sine theta.
Ooh, so are you talking common denominator? So first fraction doesn't change. What happens to the second numerator?
Sine
And some of you can already see what's going to happen here. Yay, dance of joy, QED. This is really common in the sine 2 theta identities because it's how you're going to get this 2 sine cos or sine theta cos theta. So you'll see a lot of this binomial squared. You now know what it turns into, and you'll get your 1 plus 2 sine cos. Last one, let's solve an equation with this in it. Oh, and that totally should have been x in the notation. What's going to happen on the test and the quiz, on the exam, is you're going to get into identity mode, and you're going to be like, prove, 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 and your brain is just going to look at the equation and want to prove it. So you really do need to slow down and read the instructions, and the minute you see that interval, that's not an identity. It's an equation. So you have to make sure you're out of proof mode, and we're now into solving mode. How do we solve trig equations? So we want to move stuff around, most likely. It probably involves some factoring. Once we factor, what do we tend to do? Split and solve, and then it probably involves some kind of unit circle. The trick with these ones that's new is we suddenly have this cos 2x in there. So it means we're going to have to use one of the formulas on the back of our card and swap it out. So there are 3 formulas for cos, and sometimes you go, well, which one do I use? Well, it totally matters on the question, so you want to peek on the other side. If I just have sine on the other side, which of those cos 2x formulas do I probably want to use? The one that just has sine in it. Again, I can use any of them, but what's going to happen is you're going to end up being stuck, and then you're going to have to swap out a cos squared, and you're going to end up right back at the same spot. So how do you know? Well, you look at what's in the question. Because this only has sine, we're going to take out cos 2x and put in. That's what I heard someone say. Check that it's right. And this now is just a question from last unit. So find someone in front, behind, beside you that looks friendly. I'll give you about 3 minutes to finish this off. Okay, someone want to give me the next step? So you're going to tell me, I'm just going to write it down. Which side would you like, left? Oh. Where does the 1 go? It's gone because it'll cancel with this one.
You would get 0 equals 2 sine x, or 2 sine x times sine x minus 1.
Agree? Disagree?
Then you split this all.
Janae and Chantal are fighting over it. We're good?
I got that, except my 2 sine x was negative.
Which means you probably brought over to this side.
Yeah.
So then you should have a positive here,
Yeah.
which is fine. And you can take the negative out here and leave this a positive. We'll give you the same answer. You're telling me what to write. I'm just writing down. Okay, can someone explain where this came from? So it would have been 2 sine x equals 0, and then what do we do with the 2? Divide it, and what's 0 divided by 2? 0. X equals? We're always happy when these axes values. It's way less thinking. And this one? Just pi on 2. Why not, or 3 pi on 2? Because that's 1. And now let's just put them in order so that your marker can find them and it's really easy to see. Put them in order. That was a little painful. And then it's always really handy if you box them, the markers like that, because then we can see it, it's clear, we know where your answers are. Some of you, this may come as a shock, are not the neatest people out there when you write your math. So it's really helpful if we can see this really clearly, even if this maybe isn't as neat. Not pointing out any people, but.